a1 and b1 both are 0 for each n greater than equals to 2. Let an and bn be real numbers given by this means sum of this infinite series. An and bn are sum of this infinite series, or you can say sequence of partial sum. Then which of the following is true about the sequence an and bn? Because I already said these are sequence of partial sums, and this define a sequence. So we need to tell about this sequence are convergent or divergent. If we consider an as summation minus 1 raised to the power m into m upon log m raised to the power m. After making this partial sum as a positive, means summation m over log m raised to the power m. Now test this is convergent or divergent. So we can apply root test. According to root test, we consider this as um. So we need to find limit m tends to infinity. Um means m upon log m raised to the power m and whole the power 1 upon m. Now this limit m tends to infinity, m raised to the power 1 upon m over log m. What we have, numerator part will goes to 1, and we know that this limit will be log m 1 upon limit log m, and we know that log m goes to infinity as we tends m to infinity. So we have this value is equals to 0, means L less than 0. According to root test, an, or after making positive term, this is absolute convergent, hence convergence. So an is convergent. So option C and option A has been discarded. Now check Bn or other series. As you consider Bn as summation 1 upon log m raised to the power m, it is obvious after applying root test, limit m tends to infinity 1 over log m raised to the power m by m. We have applied root test. It means 1 upon limit m tends to infinity log m, and this will also go to 0. So an and bn both are convergent. Option D is correct.